Hi, in this video we are going to test our Bellman Ford algorithm, so let's get started. First I'm going to create a list of vertices. Vertex, it's going to be a vertex list, is equal to a new array list. Okay, of course we have to import the java.util.list. Then we are going to add some vertices to this vertex list, so add, and I'm going to add the new vertex with the name, for example, A. It's going to be the vertex A. I'm going to have the vertex B and the vertex C, so B and C. I'm going to have a list of edges. Okay, for example, the edge list is equal to a new array list, and I'm going to have several edges. For example, I add a new edge and we have to specify the edge weight. Then the starting vertex, it's going to be vertex A, so the vertex list get 0 index, and again the vertex list that get index 1. The index 1 is going to be the vertex C. So with this we define that we would like to have a directed edge from A to B with edge weight 1. Then I would like to have another weight from, okay, with weight 1 it's going to be okay, from A, but it's going to point to the vertex C. And then I would like to have an edge with weight 1 from the B to the C. Of course, in this scenario, the shortest path will be going directly from A to C. We have to specify the vertex list and the edge list. Then we have to call the Bellman Ford algorithm on the starting vertex. It's going to be the vertex list on the 0 index, so basically the A. And then I would like to define the shortest path too, and define the vertex list that get with the index 2. What does it mean? That the target vertex is the vertex C. So I think it's going to print out that the shortest path is going directly from A to C. Okay, we have to reverse the list if we would like to be fancy, because here we start at the target vertex and we keep backtracking. A better solution would be to store this actual vertex in the list and then call the collections that reverse, but anyway, just for demonstration purposes, we have to read it right to left. So A to C directly. What if, for example, the edge weight is going to be very big when we considering, for example, going directly from A to C? For example, I set the weight to 10. Of course, the solution will be go from A to B first and then from B to C. What if, for example, I define some negative edge weights? Okay, it's going to work fine because this is Bellman Ford algorithm. Of course, the total cost will be -1. Going directly from A to C is going to yield -1 cost, so it's good. It's very important that the first time I met with Bellman Ford algorithm and I saw an edge weight smaller than 0, I said that okay, there's a negative cycle, but it is not true. There may be several negative edge weights and there is no negative cycle in the graph. What's very important that if we have, for example, a cycle, so an edge 0 to 1, so from A to B, then from B to C, then back from C to A, and the total cost will be smaller than 0, I'm going to comment it out in order to avoid infinite loops. This is not a negative cycle. It's going to work fine. But if the sum of this edge weight, this edge weight, and this edge weight will be smaller than 0, then it's going to be a negative cycle, like this. And what does it mean? There's a negative cycle that this algorithm is going to be infinite if we would like to find the shortest path, because on every iteration, on every time we go from A to B, from B to C, and C back to A, the average cost is decreasing. The shortest path value is decreasing. And of course we are looking for a minimum, so the best is to take as many cycles as possible, and this is why it is a negative cycle. So Bellman Ford algorithm is able to handle these kinds of negative cycles. Okay, so basically that's all about the Bellman Ford algorithm and how to handle negative edge weights and how to handle negative cycles. By the way, if you are interested that these negative cycles has a very important application in quantitative finance, because if you are familiar with the forex market, then you are able to detect arbitrage situations and arbitrage opportunities with the help of this Bellman Ford algorithm. And most of the times there are several arbitrage situations out there because of the mispricing, but these mispricings are present for milliseconds or even nanoseconds, and that's why basically high frequency trading came to be, in order to be able to gain advantage of these very short time interval mispricing and anomalies. As far as I am concerned, I think that it is a very important application of Bellman Ford algorithm as far as quantitative finance is concerned, but the algorithm itself is very beautiful. So that's all about the implementation. Thanks for watching.